Hello and welcome to our next video in our TIA or PLC programming sessions. Today we're going to talk about the S7-GRAPH or graph set. It's not exactly graph set, but it's very, very similar. So about sequential programming. What we have done so far is we have written a little function, reused it, so we have two conveyor belts here. Inside there is the behavior of the conveyor belt, and we have used it twice with different sensors and actuators, so we can use it with two conveyors, or 3 or 4 or 5 or 6. It's reusable. So the conveyors, they are standardized. They look like this. You put a part here in B1, conveyor starts after pressing S1 start. At B2, then let me push that to the side. Then a stopper will open. We're going further. B3 conveyor stops. Also this one retracts here after the B2 is not active anymore. So a rather simple system. And now we're going to not have it as a circuit, as a ladder diagram circuit. We are going to have it as a graph circuit. And a graph circuit is better for sequential programming where you have specific steps. So our first step is going to be from B1 to B2. Step 1 is conveyor on. Step 2 will be opening the stopper. Step 3 will be closing the stopper. The conveyor is on all the time now. Step 4 will be going on here. No, that's still step 3, step 3, step 3. And step 4 will be stopping the conveyor when we're at B3. Then we're done. So it's not too complicated. Let's start for this. Because I have used functions here, I can simply say I don't want that anymore. I just deleted them out of main because they are functions. I'm not calling them anymore. The PLC won't do anything with them anymore. What we will do for the graph, for the sequence, I will add a new block and I will have to add a function block. The difference between a function and a function block is that a function block has a memory, a dedicated memory space, a database, where it stores values. We are going to need, for example, the step number. Which step are we in right now? Are we waiting right now, or are we in the step where this gets here, or are we in the step where it's here, or are we in the step where it waits here? So needs to have a number to those steps. That's just an example, but there's more data behind. So we will need a function block for this dedicated data space. This block I want to call conveyor sequence. The name doesn't really matter, but I like organized names. And then I have a 5 different languages I can choose of. Actually 6, Proteac, yeah, okay. We've programmed a ladder diagram so far. Ladder, function block diagram, and statement list. Those 3 are very similar. So in what we can do with them, SDL is more like C or assembler. It doesn't really matter. And we are going to go with the graph, which is for sequentials or sequences. So graphs, and I'll hit OK. And here we are. It's going to open a new graph block where we can program our sequence. Right? We can program our sequence. Our sequence consists of 2 components. We always have a step where something happens, and we have a transition that asks for a condition to go into the next step. That's what it is. You can say this is a little gate. This gate can only open if a condition is true. So we will first create the sequence and then fill out what's happening in the steps. Step 1 right now is the step where this sequence will start in. So it's going to start in the initial step. And I will call this step initial step. Right? So basically what should happen in this step is it should do nothing. It should wait. Right? This initial step is right now this statement here. Belt is empty, we're waiting for a workpiece. Then we're putting a piece here and we press start. This is our first condition to go to the next step. So B1 and S1, those are our conditions to go to the next step. So this I will call waiting for piece. Then we can go to our next step. As soon as we've waited for the piece, we can go to the next step. And on the top here, I have my favorites with the structures I can use. I can also find those structures here on the right on basic instructions. And what we're looking for is a step and a transition. Or basically a step actually first. So the second step will be from here to here. Right? So I can call it start conveyor. I would say start conveyor. Start conveyor. That's my first step. That's my second step. When do we know that we have to go to the next step? Of course, whenever we reach B2. So my next condition here, my next transition will be B2 in center position. Let's call it in center position, right? Because this is in the center position here. Then what happens in my next step? This will open. So I will always, a step and a transition always go together. So you should always, the left one makes the most sense, always a step and a transition together. Next step will be open stopper. Then we close the stopper as soon as we get out of B2. So the next step the next transition will be not in center. Did I say here center position? Yeah, let's keep it good. Let's say also not in center position. Position, yes. Sorry, it's already late here. No, not too late, but late enough. What's the next step? The next step is going from here to the end. So I will say continue conveyor. And we know that it's done when in end position. So this time I wrote it correct from the beginning on. And then K1 will turn off, so belt will turn off. This will also be turned off. So this is exactly the statement from the beginning, the initial step. So as soon as we are here in the end, we can go back to our initial step. And we can do this with doing a jump, which is a little S here. That indicates a step. After a transition, we have a step. A jump to another step. And this will be our sequence. Now, when we are in the end position, right? When we are in the end position, we can go back to our beginning. Right now, from here, we can go back to our start position. But actually, I would like to have this statement first. That we have to take this off, right? So I want him here in between. I want another step in the transition. Well, I can just click on it. I want this after this transition here. And here I want to wait for empty belt. And then I want belt empty, right? So this is my last statement that I have to take this actually off. Now all that's left to do is actually filling out those single steps and transitions here. Let's start with the transitions. I can simply open them by clicking here on the symbol to the left. This will open a ladder block. I can also translate those by going to the properties section of my conveyor here, and I can say function block diagram rather than this. Right. By right-clicking here on conveyor on my function block for this, I can change the language, and then those will be in function block, but let's keep it with the ladder. So the first condition is there's a part here, right, and S1 is pressed. So the first condition is B1 and S1. If I would like to make this this reusable, I could now use data block bits, but let's keep it with the same conveyor belt right now. So it's more about the graph here and not about the reusability. So B1 and S1 I want to use. Let's go to the next transition. The next is true as soon as there is a part here. So the next is simply B2. The next is actually then the stopper is going to open. The next is whenever we leave B2. So we can say B2 not, right? B2 not, there we go. Next will be when we're in the end position here with B3, but B3 was a normally open, normally closed contact. So we want to ask for B3 not active anymore, just because it was a normally closed sensor. So B3 not active anymore. It sends a 0 whenever there's a piece. It sends a 1 whenever there's no piece. Now I want to wait until there is no part in the end anymore. So this is when I read a 1 again on B3. Here we go. So those are our conditions to always go to the next step. There we go. I can close this. Pretty simple. And now all that we need to do is do the contents of the step, saying what should happen in each individual step. So in the initial step, let's keep that empty for now. The start, because nothing happens in there, right? That's what we think. We'll get to it in a second. In the step 2, whenever we're here and we press S1, what should happen? Conveyor should go on, right? I can open, on the top right here, I can open this little block. If you double click on the step, a strange view will open. This is the step view, where you can change everything for this single step here. If you don't want that, this is just a detailed view of this one step. You can just double click here on the left on the sequence again, or on the top left. You have the different views here, and I just want the how's it called? Step view? The sequence view, yeah. So we want to start the conveyor here in the beginning. And how do we want to start it? I am using 4 different things in this scenario here. I will use here for the conveyor as an set, an S, because it should stay, it should turn on, it should stay on, even if it's not in the step anymore. So I want to set the conveyor, and there's qualifiers. If you see this, there's different qualifiers, and I want to set it to 1. And which one do I want to set to 1? It's K1. K1 is my conveyor. So that's the first thing that's going to happen when we press B1, when B1 is active and we press S1. Then it's going on, conveyor set, it stays on. We are reaching B2, right? We are in center position, we open the stopper, and here I want to say N. It's the qualifier. The qualifier is N. N means do something as long as you're in the step. Turn something on, so make it a 1, as long as you're in the step. If you leave the step, it's going to set to 0 again. So N, and I want this to be 1 and 1. And 1 and 1, that's the stopper. So now when we're in step 2, the stopper is going to open. As soon as we leave step 2, the stopper is going to close automatically, right? Because it's not with the N anymore. Since we do not put it into the step 4 here, we do not have this anymore, and 1 and 1, it automatically returns to the start position. It automatically turns 0 again, the output. So I don't need to reset it here or something. That happens automatically, right? I just keep it empty. We're going into the next step. We are leaving the step, meaning this we turn automatically to 0 because we only have the N qualifier. It's no set, it won't stay on, it just is on as long as we're in the step here. So we're going to the next step. We're leaving B2 here, meaning going to the next step. And in the next step, 1 and 1 is not active anymore. There's a return spring in this one, so it will return automatically. Great, so we don't even have to put anything in here. Then we're reaching the end position. Going into the end position, what do we want to do? We want to turn off the belt. And since we said the belt turns off with the S, with the set qualifier, K1 is on here, it's on here, it's on here, and it should turn off here with an R, reset. We want to reset K1. Here we go. Done, right? This is our sequence. This is all the steps that we need to take. And as soon as we take off the piece here, we're going back to the beginning, to the initial step. Now, one thing that we need to think about for later. Yeah, I'm going to make a second video just for that. So something we don't need to think about for now is the initial step. So I will talk about that later on. The only thing here, you see a difference between the first step and the second step. It's those two lines around it, right? Those two squares, those just indicate that this is the step we're starting in. If I right click on this one and say this is the initial step, right click on this, this is not, then now the sequence is going to start in step 2 already, which we don't want, right? Sometimes you want to start, you have different sequences, you could start anywhere, but we want to start here in the initial step. And I want to save the project. And all that we need to do now is go to our main, take our conveyor sequence, right? And put it on the network 1 or network whatever, put it in our program. Now it asks me to create a database. So this database is an instance database. An instance database is a database that has all the data for this specific function block here, the blue one, has all the data, so the step number and so on, the timings and a lot of things actually it has in there. I want to create a new one. It automatically gives a name and a number, so I always keep that automatically. I hit OK. And now I see this strange block looks a little bit like an integrated circuit, is now connected to my main. And this is automatically called now. If we don't put anything on the left and right, this is what we're going to do for now. If we don't put anything, then the sequence here is called automatically in automatic mode, and it's just going to do whatever it's supposed to do. So it's starting in the initial step, then it's waiting for this. If this is true, then it's going here, and so on, and so on, and so on. So pretty much done. Let's see that in the simulation here. Maybe I should have started the simulation in before, because that would have made sense, of course. But now we're sitting here. Bear with me for 1 more minute, and then we're done. So this takes a minute to start up. That's how you simulate. Repetition on simulation. You click here on top on the little PC. After selecting the PLC, this window is going to open. This is my simulated PLC. My download window here is going to open. I load my program into this little simulation. I want to start the PLC. And now it's in here. So my simulation. Why can't I push this anymore? Is my PC too slow? Nope. Now I can go in my main, for example, go online with those glasses, right? And I can see this one is active. It's all green. Green means active, right? Logic 1. And if I go in here, I can also go online and I will see we're right now in our initial step. So graph is very good for analyzing the sequence itself. So what happens here? Nothing. Okay. And you see this is in the database, for example, we are already in the step for 37 seconds. There's more to the database. And now we're waiting for this. Both of those are not true. If I want to test it here in my little sequencer, in my little simulation, I click on the extended mode. Simulation is going to open. And yes, sorry, if you know how simulations work, then you can already quit the video. You can already exit it because I'm just going to show how the how this works. I already have a simulation, but I could create a new one. I'll just call it project 1 for now because I don't really care. It's creating a new simulation right now. I can do that because my PC is very fast. That's why I can do it in a minute. I hope I can be done before minute 21 of this video. It's already 19 minutes, 19 seconds. So now I've got my system here, my simulation. I've got my PLC downloaded, right? It's loading the configuration right now. It's downloading, it's compiling if everything is okay. Because the compiler actually for 1500 is inside the 1500, not inside the PC anymore. Here we go. I have my simulation tables. I can synchronize, and now I can use this in the simulation here to, so I don't need those. I don't need P4, I don't need P5, I don't need P6 because those are on the other. I don't need those. Don't need you, don't need you, don't need you, don't need you. That's it. I've got my simulation here, and now my, can I make that a little bit smaller? Yes, good. Now my sequence is waiting for B1 and S1. So if I turn on B1, hey, you can see B1 is active here, green, logic 1, and I can click S1. Boop, we're in step 1, in step 2, which is starting the conveyor. Do I have this little pin? Nope, nah, that's stupid. I can turn those off because we have made it. We have started the conveyor. We are now waiting for B2. And you can also see here the conveyor is on. B2, click. We're now in the next step, the open stopper. B2 not active anymore. And I can see that K1 already turned off because we have reached B3 already. Right here the condition, whoops. Here the condition was actually reaching B3. And since B3 is a normally closed sensor, I should have done that from the beginning on. Now that's fine. Our sequence is done, right? We've been through once. Perfect. Great. Now I want to make some changes to this. Some very, very easy, simple changes to our system itself. All right, so 21 minutes so far. I can still do some minutes, so bear with me. Very simple things. I want to add a sensor. All right, this I want to call B4. B4 now is responsible here in the center. Oh, let's call it B20 because it has to do with this one as well. This is a, let's say, color detection sensor. We've got green parts and we've got gray parts. Green parts, if they are here, they will send a logic, B20 will read a logic 1, indicating this part is okay. And then we go to B3. If it's a gray part, B20 will send a logic 0, and we will go back here to the start. And we will go back to the start. So let's do this. First thing I need to add in my conveyor here is, of course, the sensor B20, which is then input 10.4. So that's the free color detection. And now assume I also have on K1, I have a second output to make it actually run in the other way. I will call that K1.1. And this is Q4.2. 4.3, sorry. I already have 4.2. As you can see, perfect here. And this is conveyor belt reverse. So now that I've got this, I can make those changes here in my sequence. So I've got my initial step, nothing changed here, right? Nothing changed there, nothing changed there, nothing changed for starting the conveyor. The next thing is here in center position. So if everything is okay here, right now in the center position, if we have this part, we mean B2 is active and B20 is active, indicating we've got a correct path. So this will be the correct path, B2 and B20. This will then do exactly what we had before, right? In our sequence, this will just stay the same. What I want next to this is actually a parallel path. So I can click on the step, and on the top here we have something called alternative branch. There's also simultaneous branch. That's not the thing we want right now. We want an alternative branch. Let's click on it. You can see it's really an alternative. Either if this is true, so if B2 and B20 are true, we go this path. If this here is true, we will go this path. So this will be in center, wrong part or gray part. Right? This will be exactly like those, but with the difference that B20 is not active, so normally closed. Here we go. So this happens if we have this gray piece here. We're going here. And now what we want to do is not open the stopper, but reversing the conveyor. Right? So what we will do is a new step. With those on the top here, with those two blue ones, you can open and close all the steps and all the transitions if you just want to organize the structure. That's very convenient. This is conveyor reverse. Then the next would be that we are here in the start again. Back at start. Then someone takes the piece off, right? Wait for empty belt. The problem is that you can't have the same name twice, so I will just wait for empty. I could also put a number there. So back at start first, it's if B1 gets active, and wait for empty is, of course, now B1. Oh, not active. Here we go. And in the end, we want to go back to initial step. So what happens in conveyor reverse? Of course, we want to reset our conveyor forward. If we turn on both, the conveyor could break because we're trying to push in both directions. And I want the conveyor reverse to be on. How long do I want the conveyor reverse to be on? Here. So we start here and we go there only in this step, right? As soon as we're here, we're waiting, we turn it off again, so I can say N for only in this step, and I want K1.1, and I'm done, right? Wait for empty, we don't do anything, we wait, and this automatically turns off K1.1, the reverse conveyor, because we don't have it in here anymore, it's just this N. So, there we go, that's it. We have made a parallel branch, an alternative branch, and our structure will now run this path here if this is true, and it will go to the left if this is true. Done, pretty much. Right? So I could now simulate that again, but I think you get the idea. That should be enough. Yeah. That's it for the graph. I could also now temper a little bit with the, oh, now I've changed something in there, so I have to, this is now red, I just have to compile again, right, because there were changes. There's an interface on here. Let's also, yeah, I still have 3 minutes, then we make the half an hour, perfect. We have this interface here. At this interface, and there are some parts important on this call here, and I just will explain the most important ones. We have SW auto. This is basically if the automatic mode is active. I won't take anything right now. You usually have a selector switch that says automatic mode or manual mode or so. SW auto means automatic mode is selected, right? So the selector switch is in automatic mode. Then basically, this is just what we have. This is just what we have. Right now, the conveyor belt runs in automatic mode in our case. If I wanted to run it in step mode, so I press start, every step I have to press start. This is the tab mode. The tab mode selected. That will be start one step, start second step, start third step, and so on. So every button press is one step, and I need to also put that next step button because the sequence needs to know which is the next step, right? The next step button here on T push. The only last thing I also usually put on here is sometimes I want to reinitialize the sequence, so a reset button, and the reset brings my whole sequence back to the initial step, right? So I could press reset right now when I'm in the open blocker step here, and it will bring me back to my initial step. The only thing I need to think about now is if I have a set, for example, then I will not go through the reset step here. So I have to reset everything in my initial step, right? Because this is where we're jumping to, so we're not going through the other steps. We will just directly jump here. That's why we need to have the reset statements in there as well. So I will just say here, this is my reset mode selected. And that's what I want to do here. One more is sometimes you have a stop button or a stop mode. I will say stop button from somewhere, and this will turn off the whole sequence. And after turning it off, you have to reset it again, and then you can run it in any of those modes. Good. So now that those are read, let me do the last thing. I want to define those as tags, right? And I will have those as inputs, and I will just have to see which is my next free input. Therefore, I can go into the brain, tools, assignment list, and I can see I have not used input byte. Whoa. Didn't I use 11? I thought I used 11. I used 11. I haven't used it in the program. That's why it doesn't tell me. So let's take the because it's 4 more inputs. No, let's take 12, 12.0, 12.1, and so on and so on. So you I 12.0, I 12.1. I just do that because I can't leave a program not be done. I 12.3 and I 12.4. Good. Now that we have our interface, my sequence will react on those different modes here. So it won't always run automatic mode. We have 3 different modes. We can reset it. Actually, we can stop it, we can reset it, we can run it automatic. That's what we always did before. And we can run it in automatic with every single transition. So every condition, we have the start button basically added to it. So we have to press start between every step. Here we go. I could now simulate that, but I won't because I'm running out of time. It's 31 minutes. And I think it's a good overview of the S7-GRAPH here, right? So if you've got any questions on this, just leave a comment below. I hope you learned a little bit. If you did, press the like button, subscribe, and I'll see you in the next video. Thank you very much for watching. And yeah, have a nice day. Bye bye.